Okay, welcome to today's lesson on scientific notation. So in chemistry, we're often going to work with very large or very small numbers. So for example, the Hope diamond, one of the largest diamonds in the world, contains approximately 460 lots of zero atoms of carbon. It's a very large number. Or you can look at very small numbers. Each of these carbon atoms has a mass of lots and lots and lots of zeros, 2 grams. That's a very small number. Notice how far behind the decimal it is. It's going to be a lot easier for us to express these very large or very small numbers by writing them in scientific notation. In scientific notation, a given number is written as the product of two numbers. So remember, product means multiplied. We're going to multiply a coefficient and 10 raised to a power. So our number from up above, 460 gazillion gazillion, is much more easily stated as 4.6 times 10 to the 23rd. And the mass of that one carbon atom, 2 times 10 to the negative 23rd grams. These numbers here, those are the coefficients I mentioned just a second ago. Those numbers multiplied by 10 to the power. When you're writing your coefficient, it has to be between the numbers 1 and 9. The power of 10 represents how far in front of or behind the decimal point the actual number is. So a positive exponent is used for numbers in front of the decimal point. And a negative exponent, again, these are the exponents after the number 10, the negative exponent is used for the numbers behind the decimal point. So well-known conversion, I think we're all pretty familiar with 1,600 meters in a mile. If we're going to move the decimal point, remember our coefficient has to be a number between 1 and 9. So we have to move the decimal point to behind the number 1. That's 3 times. So our exponent behind 10 is 3. 1.6 times 10 to the third meters in a mile. Let's take a look at a small number. There are 0.000011574 days in a second. Again, we have to have a number between 1 and 9 for our coefficient. So we need the decimal point between this one and that one. Because we move the decimal point 5 times, our exponent is 5. Notice, though, that this time we're moving the decimal point to the right. That means we're going to have a negative exponent. So there's 1.1574 days in a second. Some quick examples here. So we're given the scientific notation. We would write that in standard notation. Again, we're moving the decimal point 6 places. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6,300,000. Going from standard notation back to scientific notation, there has to be an implied decimal point right here behind the last 0. So if we bump it to the left, 1, 2, 3, 4, there's that exponent 4, 9.47 times 10 to the 4th. Standard number, again, this time we're going to have to bump the decimal to the right. That means a negative exponent. We're going 3, 4, 5, 6 places. So 8 times 10 to the negative 6th. Again, that negative tells us that our number is behind the decimal place. And again, going from scientific notation back to standard notation, 7.36 times 10 to the negative 3rd. Moving the decimal point from 7, we're going left because we have the negative decimal point. We want a number smaller than 1. 1, 2, 3. 0.00736. Working with calculator. This is going to be a very important skill this year, is working with your calculator. I highly recommend that you guys have this TI-30X. And here is the best way to use scientific notation with the calculator. So hit that second button, it's up here in the top left, followed by the button directly next to it, DRG. You'll then be presented with three options. You'll want to use the arrow button to come over to psi, and then hit enter down here at the bottom. If you want to return to standard notation, or the normal notation, again, hit that second button followed by the DRG button, and this time you want to choose flow, again, followed by the enter button down here at the bottom. So why might it be important to view a number in scientific notation on your calculator? As an example, let's take a look at the calculation before, where I figured out how many days there were in 1 second. Now we're not here math-wise, we might not be here math-wise, so I've done the math for us. All we want to do is plug this into our calculator. First things first, make sure you are in flow, that's the standard notation. Go ahead and enter 1 divided by 60, divided by 60, divided by 24. Your value should be 0.000011,574. Fantastic. Next, let's go ahead and convert that back into scientific notation. So hit the second button, DRG, psi, enter. You should notice your number changed. Your last number is no longer a 4. You just added 5 more digits after that 4 by going back to scientific notation. So the problem with your calculator is when it's in standard notation, it only has so much room to display the value. So it's oftentimes going to round off the last several digits. If you're working with scientific notation though, it can report to you a lot more digits because it doesn't have to work with these zeros between the decimal point and the first number. There is a test question, or at least there typically has been a test question, where you make a calculation just like this, and if you don't use scientific notation, you'll round off your answer because you're just reading the calculator. So you round off your answer too much, and you'll end up losing half a point. So make sure you guys are using that calculator correctly. Get in the habit of always checking second, DRG, scientific notation. Do you have all the digits that you need? All right, how best to enter a scientific notation number onto your calculator when you're using it in an operation like division or multiplication. Using your calculator is going to be very important this year, so make sure you guys are following these steps and getting better with it every single time you use it. So I highly recommend what I call the Big E button. So when you use a number in scientific notation in an operation, use the Big E button. It's located above the 7 on your TI-30X. To access it, you have to hit the second button again, followed by the inverse button next to the -1. Before you do that, though, make sure you guys have your coefficient entered. You follow that Big E button with your exponent, and voila, you'll have your scientific notation programmed into the calculator. What the Big E button does is it fills in for times 10 to the caret symbol. So if you were used to using times 10 to the caret, this eliminates that. I know it might take a little bit of practice, it might take a little getting used to, and that might slow you down at first, but I promise you long term, it will speed you up. It's fewer total keystrokes, so that saves you time. Also, big advantage, you don't have to worry about the order of operations. If you're using times 10 to the caret sign, you have to follow the order of operations, otherwise your calculator is going to spit out to you the wrong number. So give that Big E button practice. In fact, I'm going to walk you through a number right now, or an operation right now where we get some of that practice right here. So 1.34 times 10 to the 19th times 5.44 times 10 to the -9th. So first off, start off with your first coefficient, 1.34. Next, let's hit the second button, followed by the inverse button. Again, that's the button just above 7. Go ahead and enter your first exponent, 19. At this point, your calculator should display this right here, 1.34 Big E 19. No time symbols, no 10, 1.34 Big E 19. Next, enter whatever operation you're working with, in this case the multiplication symbol. Go ahead and enter your second coefficient, followed by the second inverse button, and go ahead and enter your second exponent, -9. Go ahead and press the equals or enter button, and your value on the computer should be 7.2896 times 10. If you're not getting that, go ahead and pause the video. Try again. But again, practice makes perfect. Start getting used to that big E button. We're going to use it a lot this year. Again, a few more examples. You may want to use them on your calculator. This is very similar to what your homework looks like. So let's make sure we're all doing them correctly. 6.02 big E 23 times 9.63 big E -2. Again, advantage of that big E button is we won't need these parentheses. I've got them in here because it clears everything up and makes everything look a little more organized on the slide, but on your calculator you won't need those if you're using that big E button. Hopefully the value you got was 5.79726 times 10 to the 22nd. 5.6 times 10 to the -18th divided by 8.9 times 10 to the 8th. Again, we can enter that into our calculator as 5.6 big E -18 divided by 8.9 big E 8. Press the enter button, and hopefully the value you're getting is this one here. And finally, a mixed operation. We have multiplication on top, division on bottom. 8.2 big E -3 times -7.9 big E 7 divided by 7.3 big E -16. Hopefully we're all getting -8.873972,603 times 10 to the 20th. Again, get that practice in with your calculator. That's going to be a lot of what your homework is tonight. Good luck, and we'll see you again tomorrow.